Hello everyone, welcome to La Excellence. We are making continuous series of space technology in science and technology, which is very important. In today's session, we are going to discuss about the types of orbits. We can see the types of orbits depending upon the location, how far they are from the Earth and how near they are from the Earth. So there are many different kinds of satellite orbits that can be depending upon the satellite's functions and area it is to serve. So, lower the satellite orbit to the Earth, the stronger the gravitational pull will be, right? So, if the gravitational pull is high, that means the satellite must travel faster to counteract this pull. So, farther away, the gravitational field is less. So, that's why the satellite velocities are correspondingly less. So, satellite orbits the Earth in two basic types. First one is the circular one, another one is the elliptical. For circular orbit, the distance from the Earth it remains the same at all times. You can see it is same everywhere. Whereas in the elliptical orbit, the distance changes. So we can see here the distance is more and distance is less in here. That's how it varies. So, circular orbits are again classified into low Earth orbit, geosynchronous orbit, and medium Earth orbit. So, most of the satellites, the International Space Station, Space Shuttle, and Hubble Scope Telescope, are located in this low Earth satellite. So we can see the distance varies from the low Earth orbit distance varies from 180 kilometers to 2000 kilometers. And it is convenient for installation of new instruments and fixing some of the broken elements which are present in the satellite and for inspecting for the damaged things which are present in the satellite also. And if we come across this geosynchronous orbit is also called as geosynchronous orbit is also called as geostationary orbit. So it is located 35,790 kilometers away from the Earth's surface. So a geosynchronous orbit it is located 35,790 kilometers and has the same orbital period as the sidereal rotation period of the Earth, and it allows the satellites to synchronize the rotation of the Earth only in the time but not in the direction. Only in the time. That means they have 24 hours but not in the direction how the Earth is rotating. So this makes these geosynchronous satellites particularly useful for the telecommunications and remote sensing operations. Remote sensing operations. So one particular form of this geosynchronous orbit is geostationary orbit, in which the satellite rotates in the same direction as the rotation of the Earth and has the approximate period of 24 hours. And the satellite which is placed in this geostationary orbit remains in the same position relative to the Earth, and it is used by the many applications included direct broadcast, broadcast, as well as the communications and the relay systems as well. While these geosynchronous satellites can have any kind of inclination, like geostationary orbit lie on the same plane as the equator. Here we can see the equator, they can lie on the same place just like the equator. Next comes the polar orbit. Polar orbit. Satellites placed in this polar orbit have an inclination of about 90 degrees to the equator, and it travels to the north and south poles over the poles. This here we can see the North Pole, and here the South Pole. It travels over the poles at lower altitudes. At lower altitude. So, at a satellite which is there in the polar orbit approximately takes 90 minutes for the full rotation, and as a result, a satellite can observe entire surface in the time span of 24 hours. So, they are often used for the applications. What are the applications of these polar orbit satellites? They are used for monitoring crops. They are used for monitoring crops and forest, and sometimes it is used for the global security. Global security means different kinds of activities which takes place near the borders or in the seas or in the oceans, like how they observe the different kinds of activities which takes place on the earth without a man, like it is like a surveillance camera in the sky. Next one is the sun synchronous orbit. Next one is sun synchronous orbit. It is a special case of polar orbit moving from the pole to pole, allowing the satellite to pass over any given point of the planet's surface at the roughly and same local time each day. Since there are 365 days in a year, 360 degrees in a circle, it means that the satellite has to shift its orbit only approximately 1 degree per day. 1 degree per day. So these orbits are used for satellites and that need a constant amount of sunlight and are useful for the imaging and different kinds of spying and weather satellites also. Here we can observe by observing the functions and the different kinds of satellites which are placed in the different kinds of orbits. We have seen that these are used for the telecommunication, remote sensing, and broadcasting, and sometimes the monitoring. So that's how their functions varies, and all these satellites which are placed in different kinds of orbits, they have their own functions. So that is why we can call them as cameras in the sky. So that's how they work.